Did you know that humanity once bombed the moon? What could possibly justify such a bold action, and what were the consequences? Could this event have altered our understanding of space forever? In 2009, NASA launched a mission that would go down in history as one of the most audacious scientific experiments ever conducted, the Lunar Crater Observation and Sensing Satellite, LCROSS, mission. The mission's primary goal? To bomb the moon. But why would NASA, an organization dedicated to peaceful exploration, decide to take such a drastic step? The answer lies in one of the most vital resources for future space exploration: water. The LCROSS mission was designed to confirm the presence of water ice on the moon, specifically in the permanently shadowed craters at the lunar South Pole. Water is a key resource for sustaining human life and could be used to produce oxygen and rocket fuel, making it essential for long-term space missions. The idea of bombarding the moon to search for water may have sounded extreme, but it was seen as a necessary step to prepare for humanity's next giant leap into space. When the public first heard about the mission, reactions were mixed. Some people were fascinated by the idea of uncovering the moon's secrets, while others were concerned about the ethical implications of altering a celestial body that has held a special place in human culture and mythology for millennia. Yet, NASA pressed forward, driven by the potential scientific benefits. On October 9, 2009, the world watched as LCROSS's Centaur rocket stage crashed into the moon at nearly 6,000 miles per hour, followed by a smaller satellite designed to capture data from the impact. The collision created a plume of debris that rose miles above the lunar surface, providing scientists with a unique opportunity to analyze the material ejected from beneath the moon's surface. The immediate results of the mission were both groundbreaking and controversial. The plume revealed the presence of water ice, confirming that the moon harbored one of the essential ingredients for life. This discovery reignited interest in lunar exploration and opened up new possibilities for future missions, including the potential for establishing a lunar base. However, the mission also sparked debates about humanity's role in space exploration. Was it ethical to bomb the moon for the sake of science? What are the long-term consequences of such actions? As we continue to explore the cosmos, these questions remain at the forefront of our minds, reminding us that every step forward in space exploration comes with its own set of challenges and moral considerations. On October 9, 2009, the LCROSS mission reached its climax as the Centaur rocket stage slammed into a crater near the moon's south pole. This impact wasn't just a simple collision, it was a carefully planned event designed to maximize the scientific yield. Traveling at nearly 6,000 miles per hour, the Centaur rocket hit the moon with such force that it created a crater and sent a massive plume of lunar debris soaring into space. Following the impact, a trailing satellite equipped with an array of sensors, cameras, and spectrometers captured every detail of the event. This satellite, designed to analyze the dust and gas thrown up by the collision, relayed data back to Earth in real time. The goal was to detect water ice and other volatile compounds hidden beneath the moon's surface. As the plume rose, the instruments on the satellite confirmed the presence of water, an astonishing 100 liters in the form of ice, spread throughout the debris cloud. This was a pivotal moment in lunar exploration, as it provided the first direct evidence that the moon harbored water ice in significant quantities. For scientists, this was a game-changer. Water on the moon could mean a future where astronauts could extract and utilize it for drinking, making oxygen, and even producing rocket fuel, all on site, rather than hauling these essential supplies from Earth. The immediate scientific results were hailed as a major success, but the mission wasn't without controversy. The sight of a rocket crashing into the moon, an object that has been a source of wonder and inspiration for centuries, left many people uneasy. Some question whether humanity had the right to alter other celestial bodies for our own purposes, no matter how noble the scientific goals might be. In the days following the impact, debates erupted in both scientific and public forums. Was it worth it to disturb the moon's pristine environment? What were the potential long-term effects of such an intervention? These questions added a layer of complexity to the mission's outcome, highlighting the delicate balance between scientific advancement and ethical responsibility. The LCROSS mission's results had far-reaching implications. Not only did it prove that the moon contained water, but it also set the stage for future lunar exploration. Yet, it also reminded us that space exploration isn't just about the pursuit of knowledge, it's about understanding the broader consequences of our actions as we venture beyond our home planet. The discovery of water on the moon was a milestone in space exploration, with far-reaching implications for future missions. Water is essential for sustaining human life, and its presence on the moon opens up a range of possibilities that were once considered science fiction. First, the water ice found in the lunar crater can be broken down into hydrogen and oxygen, which are key components for making rocket fuel. This means that future missions could potentially refuel on the moon, greatly reducing the cost and complexity of space travel. Instead of launching all resources from Earth, astronauts could use the moon as a stepping stone for deeper space exploration, such as missions to Mars or even beyond. Additionally, the presence of water could support a permanent human presence on the moon. A lunar base could utilize local water for drinking, growing food, and generating oxygen, making it more self-sufficient. This concept of in-situ resource utilization is central to many of NASA's long-term goals and has sparked increased interest in returning to the moon. The LCROSS mission also demonstrated the effectiveness of using impact-based exploration to uncover hidden resources on celestial bodies. This approach could be applied to other missions, such as exploring asteroids or the moons of other planets, where similar techniques might reveal valuable resources or new scientific insights. However, the mission also raised questions about the ethics of such interventions. Altering the moon's surface, even for scientific purposes, has led to debates about humanity's responsibility in preserving the natural state of celestial bodies. These discussions have become increasingly relevant as space exploration advances, with multiple nations and private companies planning missions that could further impact these environments. In summary, the LCROSS mission didn't just confirm the presence of water on the moon, it paved the way for future exploration strategies and raised important questions about how we interact with other worlds. The implications of this discovery are still being explored, and it continues to influence space exploration policies and plans to this day. The discovery of water on the moon was a major success, but it also sparked a wave of theories and speculations. While the LCROSS mission revealed crucial scientific data, it left some questions unanswered and opened the door to new mysteries. One of the key areas of speculation revolves around what else might lie beneath the lunar surface. The discovery of water ice hints that other valuable resources could be hidden in the moon's shadowed craters, potentially including rare minerals or compounds that could be vital for future technology. This possibility has fueled interest from both national space agencies and private companies, all eager to explore the moon further. However, the mission also highlighted potential risks. Some scientists and ethicists worry that our aggressive exploration tactics, such as bombarding the moon, could have unforeseen consequences. Could these actions destabilize the lunar environment in ways we don't yet understand? While the impact from LCROSS was relatively small, it raises broader concerns about how repeated interventions could affect the moon over time. Another layer of speculation involves the potential discovery of organic compounds or evidence of past biological activity. While there is no direct evidence to suggest life on the moon, finding organic material could reshape our understanding of the moon's history and its potential role in the early solar system. Culturally and philosophically, altering the moon has also provoked reflection. The moon has long been a symbol in human culture, mythology, and religion. Changing its surface, even in the pursuit of knowledge, challenges our perception of it as a timeless and untouched celestial body. This has led to discussions about how humanity should approach space exploration, balancing the pursuit of knowledge with respect for the natural state of celestial objects. In conclusion, while the LCROSS mission achieved its scientific objectives, it also opened up new questions and potential challenges. As we continue to explore the moon and other celestial bodies, we must consider not only the potential gains but also the long-term consequences of our actions. The LCROSS mission marked a significant milestone in our exploration of the moon, providing concrete evidence of water ice and opening up new possibilities for space exploration. Yet, as with any major scientific breakthrough, it also raised important questions and challenges that continue to shape our approach to space. The confirmation of water on the Moon was more than just a scientific achievement, it was a crucial step towards the sustainable exploration of space. The potential to use lunar resources to support human life and fuel further exploration is a game-changer, making the idea of long-term missions to Mars and beyond more feasible. This discovery has reinvigorated interest in the Moon as a critical part of our future in space, prompting new missions and international collaborations aimed at building on LCROSS's findings. However, the mission also served as a reminder of the ethical and philosophical questions that accompany space exploration. The decision to bomb the Moon, though scientifically justified, highlighted the need for careful consideration of the impact of our actions on celestial bodies. As we move forward with plans to explore not just the Moon, but also Mars, asteroids, and other parts of our solar system, these ethical considerations will become increasingly important. The LCROSS mission has also encouraged a broader discussion about the future of space exploration. Should we focus solely on scientific discovery, or should we also consider the preservation of celestial bodies as we find them? How do we balance the need for resources with the desire to keep the cosmos as untouched as possible? These are questions that will need to be addressed as humanity takes its next steps into the final frontier. In conclusion, the LCROSS mission was a landmark event that advanced our understanding of the Moon and its resources, but it also reminded us of the complexities involved in exploring other worlds. As we continue to push the boundaries of what is possible, it is essential to remember that with great discovery comes great responsibility. The choices we make today will shape the future of space exploration for generations to come, and it is up to us to ensure that we proceed with both curiosity and care.